Hi, in this very short video, I'll be teaching you the two special logarithms. Let's proceed. From the exponential equations, we know that b raised to 1 is equal to b. Now, converting this to a logarithmic equation, we get log base b of b is equal to 1. Remember how we convert exponential equation to logarithmic equation? That is, we write log of the base b of this number that will produce this number is equal to 1. So log base b that produces the b is equal to 1. And as we can see, this is not just any ordinary logarithmic equation. It says that for every base b, when the value here is equal to b, the log is equal to 1. For example, log 3 is equal to 1 because it's b and the b. The values are the same. Log base 4 of 4 is also equal to 1. Log base 10, note that if the base is not written, it is 10. So when this is 10 and this is 10, this is equal to 1. The proof of this is always the exponential form. For instance, the log base 10 of 10 equals 1. When we convert this back to exponential form, this is 10 raised to 1 equals 10, and it's indeed equal, or the two are equal in value. So all the other logarithmic expression following the log base b of b will always be equal to 1, provided that the b is an acceptable value of b. Note, the base should be greater than 0, and base cannot be equal to 1. At the same time, this b is also or must also be greater than 0. Again, the key idea is if you have a log with a base b and the value is also the same with the base, the logarithm is equal to 1. Next special logarithm will come from the b to the 0 is equal to 1. We know that for any non-zero number, when we raise it to 0, it's equal to 1. If we will convert this to its logarithmic form, remember, it's the log of the base b that creates this value is equal to the exponent 0. And there, we have created this special equation that if we have log base b of any acceptable number, if this value is 1, the value of the logarithm is automatically 0. For example, log base 3 of 1. You notice this is 1 and there's a base. The value is equal to 0. This is 1, no matter the base. As long as it is an acceptable base, then the value is 0. Log, this is base 10. We don't need to write the base 10. But this is 1, so the log is equal to 0. So again, all the other logarithmic expressions following the form of log base b of 1 will always be equal to 0. Let us apply this in an example. Suppose we are to simplify the expression log base 5 of the expression 2 log base 6 of 6 minus log base 3 of 3. So keep in mind, the main ideas is that if we have log base b of b, this is equal to 1, and log base b with 1 is equal to 0. So try to spot something that looks similar to either of these two special logarithms. For instance, log 6, 6, log 3, 3. So if we will simplify this, this will become log base 5 of 2, but log 6, 6 according to the first special logarithm, this is equal to 1, minus log base 3 of 3 is also equal to 1. To simplify further, log base 5 of 2 times 1 minus 1 is 1. and this is exactly a version of log base b1, and we know log base b1 is equal to 0. So that's how we apply these two special logarithms. Again, log base b of b is equal to 1 and log base b of 1 is equal to 0. That's all for this very short video.